Stoichiometry and mass problems. In mass problems, you first have to change the mass of A to mass of B. The next thing you do is balance the equation. Change grams of A to moles of A by dividing by the molar mass of A. Step 3. Change moles of A to moles of B with a mole-to-mole ratio. Step 4. Change moles of B to grams of B by multiplying by the molar mass of B. Molar mass over 1 mole. Step 5. Cancel units in top and bottom, and grams of B is the answer. Now we will show an example.
Copper 2 oxide decomposes to form solid copper and oxygen gas. If 95.40 grams of copper 2 oxide decomposes, how many grams of copper and oxygen are formed? First, you need to balance the equation. Since you have 2 oxygens on the right, you need to have 2 on the left. So you put a 2 in front of the CuO. That gives you 2 coppers on the left. So you need to have 2 coppers on the right. So you add a 2 before the Cu. Now the equation is balanced on both sides.
Next, you have to change grams of A, which is our copper oxide, to moles of A by dividing by 79.545, which is the molar mass of copper oxide. Then you multiply that by the mole-to-mole ratio, which you get from the balanced equation. Then, change moles of B to grams of B by multiplying by the molar mass of copper.
Finally, you will need to cancel units in the top and bottom and be left with grams of B, which will be your answer. So you would cancel out 1 mole, copper, and then be left with CuO. Then you will divide 95.40 grams by 79.545, then multiply it by 63.546, which your answer will be then 76.2 grams of CuO.
Now we have moved on to theoretical yield. Burn 0.250 moles of CH4 and 1.250 moles of O2. How much CO2 does this produce in grams? First, you must calculate the limiting reagent, which is CH4. That means CH4 will be completely used up in the reaction. Next, you'll need to balance the equation, which is CH4 plus 2O2 yields to CO2 plus 2H2O.
If we react 0.25 moles of CH4, we will get 1.25 moles of CO2 out. Then we need to convert moles to grams, which is mass equals molar mass times number of moles. So 44.01, which is your molar mass of carbon dioxide, times 0.250, which is the number of moles of carbon dioxide, which you will get 11 grams as your theoretical yield, which is the amount we get if we use up all of CH4, which is the limiting reagent.
Mistakes to avoid in stoichiometry. Number 1. Remember, Avogadro's number is 6.022 times 10 to the 23rd, not 10 to the negative 23rd. Number 2. Know the difference between moles and molecules. Number 3. The stoichiometric ratio comes from the balanced equation.
Tips. Number 4. When in doubt, convert to moles. Number 5. Always remember to balance the equation. Number 6. Be careful when using Avogadro's number. Use it when you need it, or have the number of atoms, ions, or molecules. 7. Don't incorrectly identify the given known and the wanted unknown. Number 8. Don't use the wrong units. Number 9. Don't use the wrong conversion factor, for example, 1 mole over 22.4 liters, or 1 mole over 6.02 times 10 to the 23rd particles. Good luck! You'll ace the final.